Oh, welcome back, chemistry fans. All right, we are going to do the solution for the day 57 warm-up. So let me share my screen with you, and we will get started right away on the oxidation states, how to calculate those that we talked about last class. Share my screen and we will get started right away. All right, so we've got in this one, we've got barium and we've got hydrogen. Now, this is one of the rare ones. Now, I will not do this to you on the test because there's only 4 questions on the test. So I'm not going to try and be mean and have an exception to one of the rules. However, in this one, this is one of the exceptions to the rules. This is the hydride. So this is rule number, I believe this is rule number 4. This is the exception one. And in a hydride, we have to understand that hydrogen doesn't have the +1 charge. In fact, what it has is a rare -1 charge. And since there are 2 of them, that means the charge is -2. Now, we could have already figured that out because one of the rules that we also knew was that barium is in the second column and it automatically has a charge of +2. Since there's only one of them, that would mean that the total charge had to equal 0, which is rule number 10. And so if I were to write out the answer to this, though, you must have that barium is equal to +2. And here's where all good chemistry students would make a mistake if they did. They would not, don't write down -2. You write down the individual charge is -1. Both of them together is -2, but the individual charge, that's what the answer is. I'm never going to ask you what is the total charge of the hydrogens. I'm going to ask you what is the individual charge. All right, same thing for number 2. This is also one of those exceptions to the rule. So this would be the exception to rule number 4. This is rule number 5, I believe. Let's see, 3, 4. I believe this is rule number 5 is what this one comes to. And this is a peroxide. Peroxide has an overall charge of -2, meaning that each one of those oxygens is a -1 since there are 2 of them. Normally, oxygen, each one would have a -2, but in this case, it is a peroxide. And the only way for you to know that is if you see those parentheses around the oxygen or if they say it in the name of it. And so we know now that the total charge here is a -2, not -2 for each of the oxygens. Each of the oxygens is -1. And then because we have a rule that tells us that elements in the first column carry a charge of +1, we have a total charge there of +2. And that means that the sum of all those charges is equal to 0. Now, what would be my answer? It would be that sodium has a charge of +1, oxygen carries a charge of -1. Those are the 2 correct answers. All right, now we're done with the exceptions. Now we're getting into the more realistic. These are the questions that I would assume that you would have, if memory prevails, on the exam. So what we've got is sulfate as a polyatomic ion, and then I have aluminum as the other part. This is all going to equal out to be 0. However, we need to go and figure out what the individual charges are. Now, we could go about this 2 different ways. We could calculate the sulfate charge. It is a polyatomic. You could look it up. It has a charge of -2. Or the easier path to go through this is to just remember all oxygens have a charge of -2. And it's not O2, so I know it's not peroxide. So I can take this one here. This is a sum of -8. I'm going to write this down here a little bit lower so that it's easier to see, -8. Then what that means for this sulfate, it has a charge of -2. All of this has a charge total of -2. Let's see if I can get it to change colors. There we go. This all together has a charge of -2 here, all of the sulfate. So what that now means is that we have to go and calculate. So if all of my oxygens equal, sorry, my pen is fritzing here, is equal to -8, and the sulfur added to that somehow all has to equal a total of -2. So what would be the value of that sulfur when added to those -8s for the oxygen gives us a -2? Well, it's going to be a +6. So now we know two of our elements. We know that oxygen has a charge of -2. That's one of the rules. We just calculated from the polyatomic's overall charge that it has a sulfur with a +6 charge. Now, because there are 3 of these polyatomic ions, each one of these sulfates carries a charge of -2. That means that all of the sulfates together have a charge total of -6. That must be equal to the 2 aluminums. So in other words, I have aluminums and I have all these sulfates. And the sulfates have a total charge then of -6. And so they've got to equal out to be 0. So the total of both of those aluminums is +6. But I won't ask you what is the charge of all of the aluminums. I will ask you what their individual charge is. So we have to take that and divide that by 2. So our final answers would be aluminum is a +3, sulfur is equal to -6. I'm sorry, a +6, a +6, and the oxygen is equal to -2. So those would be my 3 final answers. All right, now we got to do one more, and this is the doozy, because this one may not actually be on your list of polyatomics. So bear with me as we develop this one together here. So I have magnesium arsenate. Okay. Arsenate is not one of the charges that you would normally know the polyatomic ion, the polyatomic charge for. So what we would do is we would flip these values backwards, and it would tell us verifiably that magnesium has a charge of +2. Now we already knew that because it's in the second column. So that's one of our answers we've already established just by using some principles that we previously knew from a different unit. We also have now that arsenate has a charge of -3. So with that, we can take this arsenate apart, and we know that all oxygens have a charge of -2, so that is a total of -6. So what is the charge of the arsenate -6 that makes it equal to -3? Well, it's going to be a +3. So now I have all of my answers. I've got that magnesium equals +2, oxygen equals -2, and arsenate equals +3. All right, this is what I expect you to be able to handle moving into your one question that you're going to have on the test next class. It's going to be one just like number 3 or like number 4, where you're going to have to calculate that all the values for the elements in the compound. Thank you very much. I wish you well. Sorry I'm not there. We'll talk with you again soon. Bye.